Welcome to this explainer. So picture this, you're sitting at home, maybe you're deep into a movie or working late on a project, and suddenly your TV flickers, or the lights just randomly dim out of nowhere. It is incredibly annoying, right? It totally breaks your focus, and worse, leaves you wondering if your really expensive electronics are about to just completely break down. The crazy part is, every single year, literally millions of dollars of perfectly good appliances are destroyed globally just because of poor power quality. Well, today we're going to put on our detective hats. We're acting as electrical engineers to systematically break down exactly why that happens. Our goal here is to completely unpack the whole phenomenon of voltage fluctuation so you can actually understand and, more importantly, protect your own electrical system.
Okay, let's dive into this. Every universally frustrating everyday problem usually has a very specific underlying technical illness behind it. When your lights dim or flicker like that, your home's electrical system is essentially showing symptoms of a disease. And today, we are going to formally diagnose that illness, figure out exactly why it's happening, and learn how to actually cure it for good.
But to really understand what's going wrong with our power, we first have to understand what a healthy system looks like. We absolutely love the rule of contrast here. In a standard domestic electrical setup, a healthy, stable power supply should maintain a steady, unwavering baseline. And your golden baseline? That's 220 to 230 volts. When you're sitting right in that sweet spot, appliances are happy, your motors hum along perfectly, and your lights stay perfectly bright without a single flicker.
But what happens when the voltage absolutely refuses to stay in that safe zone? Well, voltage fluctuation is simply defined as the instability of your voltage repeatedly rising above or falling below its standard stable range. It's basically when your voltage just constantly yo-yos up and down, completely failing to hold on to that 220 to 230 baseline. 1 second it's way too high, literally threatening to fry a delicate circuit, and then the very next second it's way too low, totally starving your appliances of the power they actually need to function.
So to really master this, we're going to follow a super clear roadmap today. First up, what is voltage fluctuation? Second, the main causes. Third, the impact on your appliances. And finally, prevention and solutions.
All right, Section 1. What is voltage fluctuation? We've just locked down the basics and our baseline. Moving right along to Section 2, the main causes. Let's get into the medical diagnosis phase for the power grid and see what's actually making it sick.
So, the crucial point is, here is your ultimate interview cheat sheet. The 6 primary causes of voltage fluctuation are overloading, incorrect cable size, a floating neutral, power system faults, loose connections, and heavy load startup. Let's go ahead and carefully break down the absolute most critical ones here so you truly get the mechanics behind those flickering lights in your living room.
And this brilliantly illustrates our very first major culprit, overloading. But actually scratch that. It's not just about exceeding the main neighborhood transformer's total capacity. It's also entirely about how the electrical load is distributed across the different phases, specifically the red, yellow, and blue phases of a 3-phase system. If we're improperly monitoring and balancing the load connected across these R, Y, and B phases, we are going to run into massive trouble. Because if just one of these phases gets overloaded while the other 2 are completely fine, any household connected to that specific overloaded phase is going to experience major voltage fluctuations. It's all about keeping things balanced.
Now, an incredibly common yet completely avoidable mistake is incorrect cable sizing. Think about it. When a house or a residential society is first built, the wiring cables are usually chosen based only on the household appliances that are sitting there on day one. But what happens 5 or maybe 10 years down the line? You buy a couple of brand new AC units, maybe a much bigger fridge, or a massive home theater system. As the home's power load increases over the years, that original cable becomes heavily underrated. It physically cannot handle all that new electrical traffic, so it essentially chokes, causing severe voltage fluctuations. You absolutely must size your cables for the future, not just for today.
Okay, this next concept is a massive technical takeaway, so you'll want to pay very close attention to this one, the floating neutral. The transformer supplying your street has a neutral line, right? And it absolutely, unequivocally must be properly grounded to the earth. If that grounding is weak, broken, or just generally ineffective, the neutral is left floating. When a transformer's neutral lacks this really effective grounding anchor, it creates incredible instability across the whole system, leading to highly dangerous voltage spikes that can instantly ruin your electronics.
We also really need to contrast 2 very different scales of problems here. On a macro, grid-level, massive power system faults, like, say, a line coming down in a bad storm, will often knock out power for an entire society, giving you a complete blackout. But on a local level, A sneaky loose wire or a carbonized, burnt contact at your main distribution board doesn't cause a neighborhood blackout. Instead, it acts as a permanent bottleneck. It creates persistent localized voltage fluctuation right in your very own home, even when the rest of your street is totally fine.
Let's trace the exact timeline of a heavy load startup. At 0 seconds, a heavy industrial machine or a massive household load, like starting up a huge water pump, is switched on. At exactly 1 second in, the voltage dips sharply, but by 2.5 seconds, it entirely stabilizes. This brief 1 to 2.5 second dip in voltage is perfectly normal to observe. It is literally just the massive initial power draw required to kickstart a heavy load. If the power stabilizes right after that 2.5 second mark, you do not have a chronic fluctuation problem.
All right, section 3, impact on appliances. Let's look at the symptoms our patient is actually experiencing.
So, while an occasional, very mild fluctuation might be pretty harmless, repeated instability is just devastating. Modern electronic and LED-related appliances have a very high chance of damage due to voltage fluctuation. Why? Because you are literally stressing out their highly precise internal microchips. You're frying those incredibly delicate circuits every single time that voltage uncontrollably spikes up and crashes down.
Let's move to and see how this builds into Section 4, Prevention and Solutions. It's time for the treatment.
Here is your highly actionable 4-step checklist of actual treatments to protect your electrical systems. Step 1, prevent overloading by ensuring your load is distributed perfectly across all phases. Step 2, upgrade your wiring by purposefully selecting future-proof cables that aren't going to become underrated as you inevitably buy more appliances. Step 3, go through your network and entirely eliminate loose, carbonized contacts by firmly tightening all connections. And step 4, if your local neighborhood supply is just inherently volatile and you can't control it, utilize high-quality voltage stabilizers. They act like a literal armor shield for your most sensitive electronics.
And I really want to emphasize this heavily. As an electrical professional, or honestly, even just as an informed homeowner, you must know that earthing is absolutely essential. Securing proper deep earthing at 2 distinct levels. First, the transformer's neutral all the way out on the street, and second, your own household's domestic earthing system will largely eliminate these nasty fluctuation problems and keep those dangerous floating neutral spikes entirely at bay.
So I'm going to leave you with this final, provocative thought to chew on today. Is your home's earthing system actually protecting your expensive electronics right now? Or could a loose, forgotten ground wire be the hidden cause behind your flickering lights? I highly encourage you to go investigate your own home's electrical safety this week. Thank you so much for joining me in this explainer. Stay curious, stay safe out there, and I'll catch you next time as we break down another fascinating topic together.